This is no regular rack, okay? This is a double-wide design based on the OCP Open Rack Wide standard developed in collaboration with Meta, and it weighs nearly 7,000 pounds. So, Gary, it took us a bit to get it up here, just so you know. But we wanted to show you what is really powering all of this AI. It is actually more than 2 compact cars. Now, the way we've designed Helios was really working closely with our lead customers, and we chose this design so that we could optimize serviceability, manufacturability, and reliability for next-generation AI data centers. Now, let me show you a few other things. At the center of Helios is the compute tray. So let's take a closer look at what one of those trays look like. Now, I can tell you, I probably cannot lift this compute tray, so it had to come out. But let me just describe it a little bit. Each Helios compute tray includes 4 MI455 GPUs, and they're paired with the next-gen EPYC Venice CPU and Pensando networking chips. And all of this is liquid-cooled so that we can maximize performance. At the heart of Helios is our next-generation Instinct GPUs. And you guys have seen me hold up a lot of chips in my career. But today, I can tell you, I am genuinely excited to hold up this chip. So let me show you MI455X for the very first time. MI455 is the most advanced chip we've ever built. It's pretty darn big. It has 320 billion transistors, 70% more than MI355. It includes 12 2-nanometer and 3-nanometer compute and I/O chiplets, and 432 gigabytes of ultra-fast HBM4, all connected with our next-gen 3D chip stacking technology. So we put 4 of these into the compute trays up here. And then driving those GPUs is our next-generation EPYC CPU, codenamed Venice. Venice extends our leadership across every dimension that matters in the data center. More performance, better efficiency, and lower total cost of ownership. Now, let me show you Venice for the first time. I have to say, this is another beautiful chip. I do love our chips, so I can say that for sure. Venice is built with 2-nanometer process technology and features up to 256 of our newest high-performance Zen 6 cores. And the key here is we actually designed Venice to be the best AI CPU. We doubled the memory and GPU bandwidth from our prior generation, so Venice can feed MI455 with data at full speed, even at rack scale. So this is really about co-engineering. And we tie it all together with our 800 gig Ethernet Pensando Vulcano and Selena networking chips, delivering ultra-high bandwidth as well as ultra-low latency, so tens of thousands of Helios racks can scale across the data center. Now, just to give you a little bit of the scale of what this means, that means that each Helios rack has more than 18,000 CDNA 5 GPU compute units and more than 4,600 Zen 6 CPU cores, delivering up to 2.9 exaflops of performance. Each rack also includes 31 terabytes of HBM4 memory, an industry-leading 260 terabytes per second of scale-up bandwidth, and 43 terabytes per second of aggregate scale-out bandwidth to move data in and out incredibly fast. Suffice it to say, those numbers are big. When we launch Helios later this year, and I'm happy to say Helios is exactly on track to launch later this year, we expect it will set the new benchmark for AI performance. And to put this performance in context, just over 6 months ago, we launched MI355, and we delivered up to 3x more inference throughput versus the prior generation. And now with MI455, we're bending that curve further, delivering up to 10 times more performance across a wide range of models and workloads. That is game-changing. MI 455 allows developers to build larger models, more capable agents, and more powerful applications. And no one is pushing faster and further in each one of these areas than OpenAI. To talk about where AI is headed and the work that we're doing together, I'm extremely happy to welcome the president and co-founder of OpenAI, Greg Brockman, to the stage.